Hello and welcome to the Chandara Academy. Today we are going to solve this exercise about limits. In the first part of the video we are going to solve limit A, limit B and limit 3. Let's start with limit A. So A of x, the expression depending on x, is equal to square root of x squared plus 2x plus 3 minus x plus 1. And we want to find the limit in x tends to plus the infinity. So usually with polynomials function like that, we want to see what is the most powerful term. But here we have something in plus the infinity that will act as square root of x squared, and here x. Okay, so we will have something like infinity minus 1, and we do not want that because infinity minus infinity is an undefined form. So what do we want to do here? We want to get rid of the square root because square root are really difficult function. So how can we do that? Let's remember the identity a plus b times a minus b is equal to a squared minus b squared. So we are going to multiply by the conjugate of this function. So here we have a, here we have b. We are going to multiply by a plus b on the top and at the bottom. Okay, is equal to, so the same thing, square root of x squared plus 2x plus 3 minus x plus 1. Okay, for this one, and we are going to multiply on both sides by square root of x squared plus 2x plus 3 plus x plus 1. So here as well, square root of f squared plus 2x plus 3 plus x plus 1. So let's develop this using the identity a plus a minus b times a plus b is equal to a squared minus b squared. So this playing the role of a, we've got a squared, so x squared plus 2x plus 3 minus b squared, so minus x plus 1 squared over this expression over square root of x squared plus 2x plus 3 plus x plus 1. Let's note that this expression, so the one on the bottom, will tend to plus the infinity in plus the infinity. Okay, so we are going to develop this thing here. So we will have is equal to x squared plus 2x plus 3 minus x squared minus 2x minus 1 over x squared plus 2x plus 3 minus x plus 1. Okay, now that we have that, we can simplify this with this, this with this, and we are left with plus 2. Okay, so 3 minus 1. And we have something which has the form 2 over square root of x squared plus 2x plus 3 plus, okay, this is a plus x plus 1. And this thing at the bottom will tend to plus the infinity in plus the infinity. Okay, so we will have something of the form 2 over plus the infinity, which is equal to 0. Okay, so let's write it down. We've got square root of x squared plus 2x plus 3 plus x plus 1 that tends to plus the infinity when x tends to plus the infinity by quotient. So by division, by quotient, 1 over square root of x squared plus 2x plus 3, so 2, plus x plus 1 will tend to 0 when x tends to plus the infinity. And this thing here is our limit a, so a is equal to 0. Perfect. We are done with the first one. Second one, we will have square root, so b of x is equal to the square root of x squared plus x plus square root of x over fourth root of x squared plus x minus x to the fourth. Okay, so now we can easily see that into plus the infinity, which are the limit we are trying to find, okay, we will have x to the fourth power, which will be the most powerful term in the expression. Okay, so now we want to prove it. So if this is the most powerful term, we will have this that tends to a large infinity and other things that will be useless compared to this one. Okay, so how do we do in this kind of situations? We factorize at the top and at the bottom by the most powerful term. At the top, the most powerful term will be x, so absolute value of x. So we will have, because we are in plus the infinity approximately, we are in positive x, okay? So x greater than 0. So square root of x squared will be here equal to x. So we've got x, factor of square root of 1 plus 1 over x, plus square root of 1 over x. Okay, perfect. So this is for the top thing, and here we've got x to the fourth, factor of minus 1, plus, so x squared plus x, the fourth root is the equivalent of 1 of exponent 1 over 4, and to factorize by x squared and put it into the square root, we have to do x to the fourth times 4, dividing, okay? So here we've got x to the x squared divided by x to the 16th, and here as well x to the 16th. So we will have into plus the infinity here something that tends to 1, square root of 1, here something that tends to 0. So just to imagine, this thing will tend to 0, this thing will tend to 1, okay, this thing will tend to minus 1, easy, and this thing here, because if we simplify, we just have 1, so let's simplify. Here we have 1 over x to the 14 plus 1 over x to the 16th to the 1 over 4 power, okay, and this thing will easily tend to 0 when x tends to plus the infinity. Okay, so now we are left with x over 4. So we've got basically something that tends to 1 at the top and something that tends to minus 1 at the bottom. And here, by simplifying this x, this x here with one of the x here, so x3, we are left with our expression b of x is equal to 1 over x to the third times all this thing here, all this thing. So we are going to write it down. So square root of 1 plus 1 over x plus square root of 1 over x over minus 1 plus 1 over x to the 14 plus 1 over x to the 15, everything to the 1 over 4th power. And so we can say that, so let's call this thing b2 of x, and let's call this thing b1 of x. We've got, so this function b2 of x is continuous in, no, so b2, the limit of b2 of x when x tends to 2 plus infinity is equal to, so we said it, this thing tends to 0, this thing tends to 0, this thing tends to minus 1, is equal to minus 1. Okay, the limit of b1 of x when x tends to plus the infinity is equal to easily 0. So 1 over something that is equal to the infinity is equal to 0. By product, limit of b of x when x tends to plus the infinity is equal to 0 times minus 1 is equal to 0. And we solved the second limit. Okay, so this one was a bit of work to arrive to the final answer. The third one, c of x is equal to, let's see, tangent of 2019 over sinus of 2020. So tangent of 2019x over sinus of 2020 x, and we want the limit when x tends to 0. So when x tends to 0, we've got tangent that will go to 0 and sinus that will go to 0 as well. So we will have an undefined form which has the form 0 over 0. Let's remember first that tangent of x is equal to sinus of x over cosinus of x. And so we've got tangent of 2019x, which is equal to sinus of 2019x over cosinus of 2019x. Okay, so we've got c of x, which is equal to 1 over cosinus of 2019x. That will go to 1 when x will tend to will tend to 0. Okay, because cosinus of 0 is equal to 1 times the quotient of sinus of 2019x over sinus of 2020x. And what limit do we know for sinus when sinus goes to 0? Okay, we do know how to solve sinus of x over x is equal to 1 when x tends to 0, and as well x over sinus of x tends to 1 when x tends to 0. So what do we want to make appear here? We want to make appear some things like sinus of some x over x. And so we want to make appear on the bottom 2019x, and at the top we want to make appear 2020x. How do we do that? So we still have c of x is equal to 1 over cosinus of 2019x. So we want to make appear sinus of 2019x over 2019x. But to do that, I also have to multiply by 2019x at the top, okay? And I can divide by 2019x because x is not equal to 0. Same thing with sinus of 2020x. We divide by sinus of 2020x, and we multiply by 2020x at the top, but also at the bottom. So 2020x times cosinus of 2019x. And now we do have something which has the form sinus of x over x, and here sinus of, let's say, y over y. And when with x is equal to 2019x and y is equal to 2020x. So when we will have little x that tends to 0, we will have x, capital X, and capital Y that tends to 0. Here we just have to simplify the x's together, and we are left by c of x is equal c1 of x times c2 of x times c3 of x, with c1 of x that is equal to 2019 over 2020, 2019 over 2020 times 1 over cosinus of 2019x. So this part of the function. And this thing will tend to, we just said it, 2019 over 2020, of course, times 1. So it will tend to 2019 over 2020 when x tends to 0. C2 of x is equal to sinus of 2019x over 2019x. This will tend to 1 when x tends to 0. And easily we've got c3 of x is equal to 2020x over sinus of 2020x, and this will go to 1 when x tends to 0. And in conclusion, by product, we've got c of x is equal to c1 of x times c2 of x times c3 of x. That will go to, so we do the product of the limits, 1 to 2019 over 2020 times 1 times 1. So 2019 over 2020 times 1 when x tends to 0. And so c, so the name of this limit, c, is equal to 2019 over 2020. And with that, we've just finished the first video. Hope you enjoyed the video. See you soon. Bye.